Now discuss problem number 5. A 6-meter span simply supported beam carries a uniformly distributed dead load and live load of 70 kN per meter and 50 kN per meter. So meron daw tayong 6-meter na simply supported beam, yung uniformly distributed and dead load 70, tapos sa live load naman, that is 50 kN per meter respectively. The beam is 300 mm wide. So, 300 mm wide. And has an effective depth of 550 mm. So, from the center of your reinforcement to the outermost fiber in beam, in compression, we have 550 mm. It is reinforced with 4 pieces, 20 mm diameter bars. Check the section for shear and design the necessary shear reinforcement if 10 mm diameter is used. So, i-design natin yung spacing ng shear reinforcement natin sa beam natin. Use simplified analysis sa calculation in accordance with NSCP 2010 or 2015. F'C is equal to 21 megapascal. So, F'C daw natin is 21 megapascal. Fy or is equals to Fyt is equals to 345 megapascal. And the spacing should be multiples of 25 mm. So, para mahanap natin yung spacing, di ba, yung formula natin, kunin natin yung VU, tapos VC, VS, spacing, tapos compare sa Smax. So, para makuha natin yung VU, kailangan muna nating malaman yung value ng uniformly distributed load na nakapatong dun sa beam natin. Sir, paano po natin kukunin yan? Since NSCP 2010 yung gagamitin natin or 2015, in computing for your W, that is 1.2 WDL plus 1.6 WLL. So, WU is equals to 1.2 multiplied by yung dead load natin na 70 kN per meter multiplied by 1.6 multiplied by 50. So, you have a value of your W which is equal to 164 kN per meter. So, this is 164 kN per meter. So, ngayon, kunin ngayon natin yung VU max natin dito sa support natin. So, this is yung VU max na tinatawag natin. So, you have VU max. Sir, paano po natin kukunin yung maximum shear o yung VU max natin? So, ano lang? Ang kunin lang natin yung reaction. In what way? So, gamitin na lang natin yung formula. So, that is W. So, i-multiply natin siya dun sa 6 para maging kilonewton o para maging force. And then, i-divide natin siya by 2. Kasi paghahatiin siya ng dalawang support. So, you have a value of 492 kilonewton. So, this is equal to 492 kilonewton. Since meron na tayong value ng mga factored loads natin, mahanap na ngayon natin yung value ni V sub U. Sir, paano po natin magagawa yan? So, either you are going to use this shear diagram or yung cutting section natin. So, let's say, let us use this cutting section natin. So, for this one, para makuha natin yung VU, from the face of your support, you will going to measure a distance D. So, hahatiin natin, kukunin natin yung shear at a distance D from the support. So, that will be the value of your VU. So, meaning to say, eto yung VU natin. So, etong height ng shear diagram na to, that will be the value of your VU. So, you can use that. Pwede kang mag-refer dito sa shear diagram natin para makuha natin yung VU. Or pwede kang mag-cutting section na lang. So, for this one, mag-cutting section tayo. So, if you will going to cut that, so magiging ganito yan. So, eto yung loadings natin. So, ito yung beam natin. Ito yung na-cut na section. Tapos, ito yung VU natin na 492. Tapos, ito yung VU natin. And then, yung distance niya, that is D. Yung value D natin, 550 or 0.55. So, kapag kinonsider natin yung left section, that is equivalent to summation forces, vertical, upward is positive. So, VU is now equal to, so meron tayong pataas na 492, minus yung pababa. So, ano yung pababa natin dito? Etong uniformly distributed load, pababa. So, that is 164 multiplied by 0.55. So, the value of your VU is now equal to 401.80 kilonewton. So, with that, meron tayong value ng VU. Ang tanong ngayon, at a distance D from the face of your support, what will be the spacing? So, paano natin kukunin yan? Paano natin kukunin yung spacing? Same lang. Meron tayong value ng VU. Kunin natin yung value ng VC, VS, spacing, at saka i-compare natin siya sa S-max para makuha natin yung spacing natin. So, since meron na tayong VU, kunin ngayon natin yung value ng VC natin. So, for this one, meron tayo ditong value ng VC natin. So, that is equivalent to, since simplified lang yung calculation, 0.17 F prime C BWD. So, para shortcut na lang, kunin natin yung PVC, lagyan natin yung P, lagyan natin yan ng P. Okay. So, for this one, yung value ng PVC natin, so that is equivalent to, since NSCP 2010, 0.75 yung reduction factor, 0.17. Hindi sinabi kung anong concrete, assume natin na 1.0 or normal concrete. Square root of F prime C, which is equal to 21, multiplied by BWD na 300 multiplied by 515. So you have a value of your PVC, which is now equivalent to 96.406 kilonewton. And hanapin ngayon natin yung kalahati niyan, or yung 0.5 of PVC. So kalahatiin lang natin yan, that will become 48.203 kilonewton. And of course, in computing for the value of your spacing, so, pagko-compare natin yung VU sa 0.5 PVC at saka sa PVC. So, ano yung value ng 0.5 PVC? That is 48.203. How about VU? Ito yung na-compute natin na 401.80. How about PVC? That is 96.406. So, we're going to compare that. So, less than etong 48 natin sa 401.08. And of course, greater than yung VU natin sa PVC. Therefore, yung gagamitin nating formula is VU multiplied by PVC plus V sub S. Kung ayusin natin yan, PV sub C plus P V sub S. So for this one, para makuha natin yung V sub S, so substitute lang natin yung mga values natin. Yung PVC natin, that is 96.406 plus 0.75 multiplied by V sub S. So the value of your V sub S is now equal to 407.192 kilonewton. And of course, para makuha natin, kunin natin ngayon yung spacing natin. So that is AV FYTD over V sub S. So meron tayong AV dito na 2-legged. So dalawang stirrups. Pi over 4 multiplied by 10 squared. And then yung FY natin na given, which is 345 multiplied by the effective depth of 550. Multiplied by yung nakuha natin na V sub S na 407.192 times 10 raised to 3 Newton. So, yung nakuha nating spacing dito, that will be equivalent to 73.199 mm or, sabi dito, should be multiples of 25. So, since round down natin siya to the multiples of 25. So, that will be equal to 50 mm. So, nakuha na natin yung VU, V sub C, V sub S, at saka yung S. Ngayon, yung S, i-compare naman natin siya sa value ng S max natin. Sir, paano po yun? So, ngayon, i-compare natin ngayon yan sa VS at saka yung value niya na 0.33 square root of F prime C BWD. So, kung isa-substitute natin yung mga values dito, so that will become 249.521 kilonewton. Yung V sub S naman natin, that is 407.192 kilonewton. So, mas mataas si V sub S, so the value ng 0.33 squared of F prime C BWD. So, may need to say yung S max natin, that will not be equal to D over 2. Ngayon, compare naman natin ulit yung V sub S natin to 0.66 squared of F prime C BWD. O yung value neto, ito twice natin. So, 249.521 times 2. So, you will have a value of 499.042. Iko-compare natin siya sa VS na 407.192. So, since less than yan, so the value of your S max now, since satisfy yung condition, that is D over 4. So, ano yung D natin? That is 550 over 4. So, that is equal to 137.5. I-round down natin to the multiples 21, 20, 25 mm. So, that will be equal to 125 mm. Or, kapag S max natin is yung katambal ng D over 4, yung isa pang pagpipilian, that is 300 mm. Okay. So, for this one, we're going to adopt yung smallest value natin. So, meron tayong tatlong pagpipilian, yung 50, yung 125, at saka 300. So, we're going to adopt yung 50 mm. So, yun yung gagamitin nating spacing. So, yun yung spacing ng mga stirrups natin at a certain distance D dito. So, meaning to say, ihihilera natin siya at a certain distance D. So, meron tayong 15. So, ihihilera natin yan. So, kung ito yung ano natin, beam natin, kung ito yung reinforcement na ihihilera natin yan. So, from this, measure tayo ng 50, and then another 50, and then another 50. Hanggang dun sa dulo ng D natin. So, ilang piraso ng stirrups natin yung malalagay natin sa distance na D. So, ilang piraso kaya? So, that will be, so, yung distance natin dito, di ba, that is 550 mm. 550 mm over, so yung spacing niya, that is 15. So, we have 11 pieces. So, meron tayong 11 pieces ng stirrups na nakalatag at a certain distance D. So, susunod naman. Diba? Since meron tayong 6 meter dito. Ayan. So, meron tayong 6 meter dito. So, gawin natin is, kunin natin yung mga quarter points. So, yung kalahati, 3. E di eto, 1.5. Ngayon, hanapin naman natin ngayon yung value ng mga stirrups natin. Kung ilan. At a distance of 1.5 meter. Ayan. So, kunin naman natin yung value niya, distance niya. So, this is yung ano natin dito. Okay, VU. So, this is the value ng ano natin, 1.5. VU at 1.5. So, yung VU natin at 1.5 meters. So, for this one, same lang naman yung principle natin dito na gagamitin. So, same principle lang tayo na i-apply. So, mag-ano lang tayo ng cutting section dito para makuha natin yung value ng VU natin at 1.5 meter from the support. So, sir, paano po yun? So, that will look like this. So, magka-cut tayo dito. Magpapass tayo ng cutting section. So, meron tayo dito na force na 492 kilonewton. Tapos yung distance is 1.5 meter. And then meron tayong uniformly distributed load na 164 kN per meter. Hahanapin lang natin yung value ng V sub U natin. So we're going to summation forces vertical, upward positive. So para makuha natin yung VU natin at 1.5, that is equal to 492 minus yung pababa natin na load na 164 multiplied by 1.5. So yung VU natin at 1.5 distance, that is equal to 246 kilonewton. And after natin makuha yung VU, kunin naman natin ngayon yung VC natin. So kanina, nakuha na natin yung VC natin. Nakuha na natin yan. Ito yan. Ito yung PVC at saka ito yung 0.5 PVC. Ngayon pagko-compare na lang natin sila. So you have a value of your VU. Tapos, ito yung PVC. Tapos, ito yung 0.5 PVC. So, yung VU natin dito, that is equivalent to 246. Ko-compare natin yan sa PVC natin na 96.406. Yung 1/2 PVC natin na 48.203. So, ito naman, ito less than to. Ito naman greater than, less than, greater than. Therefore, gagamitin natin yung formula na VU, PVC plus PVS. So, yung VU natin na 246, that is equivalent to 96.406 plus 0.75, yung V sub S natin. So, the value of your V sub S is now equivalent to 199.459. And after that, kapag nakuha natin yung V sub S natin, kunin natin yung spacing. And after natin makuha yung spacing, i-compare natin yan to the S max. So let us now calculate for the value of your spacing. So kunin ngayon natin. So i-compare natin yung V sub S natin to the value ng 0.33 square root of F prime C VWD. Yung VS natin, that is 199.459. I-compare natin siya sa 0.33. Ito yung nakuha natin kanina na 249.521. Since less than yung VS, yung value ng S max natin, that is D over 2. So, ang D natin, that is 550. I-divide natin by 2. So, that will be equivalent to, so mali pa na tayo, no? Yeah, so, sige, kunin muna natin yung S max. Later na lang natin kunin yung S. So, yung S max natin dito, that will become 275 or 600 mm. So, dalawa na yung spacing natin. Next naman, kunin natin yung spacing using yung VS natin. So, that is AV FYTD over V sub S. So, meron tayong dalawang piraso ng stirrups na merong diameter na 10 mm squared. Yung FYT natin na 345. Tapos yung D natin na 550. Over yung V sub S natin, which is equal to 199.459 times 10 raised to 3. So the value of your spacing is now equal to 149.434. So since round down tayo to the multiples of 25, so that will be equal to 125 mm. So kukunin natin yung lowest sa tatlo. So therefore, adopt S, which is equal to 125 mm. So meaning to say, at a distance of 1.5, maglalatag tayo ng stirrups na may spacing na 125 mm. Kaso nga lang, yung problema dyan is, at a certain distance D, meron nang nakalatag na spacing na 50 mm. So sir, paano po yun? Eh di maglatag tayo after that. So maglalatag tayo ng separate set of stirrups na may spacing na 125. So from here, after nung D, latag tayo ng stirrups na may spacing na 125 mm. So, ito, yung spacing nito is iba. Ito yung spacing 1. Tapos yung susunod is spacing 2. Ayan. Sabihin natin, ito yung spacing 1, spacing 2. Okay. So, ilang piraso ng stirrups yung gagamitin natin? Sir, paano po yun? Number nung stirrups. Di yung buo, that is 1,500. Minus, etong nauna na hinilera natin. Yung D natin, that is 550. Divide natin sa spacing na 125. So, ilang piraso yung stirrups yung malalatag? So, you have 7.6 pieces. Wala namang butal na pieces. So, gawin natin siyang 8 pieces. Next naman is, hanapin naman natin yung value naman ng spacing. Spacing where stirrups stirrups are theoretically lang to pero in actual hindi naman terminated. So paano naman yung stirrups? Diyan. So matatandaan natin para malaman natin kung kapag yung VU natin nag-less than siya or equal sa 0.5 PVC. Meaning to say is, wala nang dadalhin pa yung stirrups natin na shear. So, meaning to say, i-equate natin yung V sub U natin to P 0.5 VC. Para mas magandang tingnan, unahin natin yung 0.5. Reduction multiplied by VC. So, that will be equal to, eto yan, that is equal to yung kalahati niya, that is 48.203 kilonewton. So, yung VU natin is 48.203. Ngayon, yung tanong dito is, what is the distance? Okay. So, mapapansin natin, pababa ngayon yan. So, somewhere here. Kasi yung VU natin sa 1.5, that is equivalent to, ano yung VU natin sa 1.5? That's equivalent to 246. Diba? So, 246 dito. So, somewhere here, nandito yung 48 natin. At this distance, nandito yung VU natin at 48. So, nandito yung VU natin na 48. Yung taas, so, taas niya is 48.203. Yun yung taas niya. So, sir, paano po natin malalaman yan? What will be the distance from the face of the support? Sabi, at this distance daw, wala na tayong reinforcement. Diba? So, nangyari niyan is, hanapin natin yung value ni X. Sir, in what way po? So, we can use yung, cutting section na lang, kahit para saan is applicable. So, gawin natin is, eto yan. So, eto yung nakat nating section. Meron tayong upward na nakapataas na 492 kilonewton. Ito yung hinahanap natin na value ng X. Yung VU natin, given naman yan, which is equal to 48.203. And then, yung nakapatong sa kanya is 164 kilonewton per meter. So, gagawin natin dito is we're going to summation forces vertical. Upward positive yung VU natin, that is 48.203 is equals to yung pataas na 492 minus yung pababa, yung 164 na uniformly distributed load, imumultiply natin siya sa distance para maging force. And then by shift solve, the value of your X is 2.71 meter. So meaning to say, at this distance, mahihinto na ngayon yung yung spacing ng mga stirrups natin kasi stirrups are no longer required on that. So with that, since wala na tayong stirrups dito, so what will be the distance? What will be the spacing? Kasi nga, wala nang spacing ng stirrups. Wala nang stirrups kasi, so wala nang spacing. So doon natin i-adapt yung S-max kapag kasi theoretically speaking, wala na nga ang stirrups kasi hindi na kailangan. Kaso nga lang sa actual, kailangan yon. Kasi mahihirapan sa pagporma yung konkreto natin o yung beam natin. So gamitin natin yung S-max na D/2 for the spacing ng mga natitirang bakal, ng mga natitirang stirrups natin or anilyo. So S-max natin, that is 275 or 600. So gamitin natin dito S is equals to 275 mm on center. So kahit na hindi kailangan yung stirrups, kailangan nating maglagay para hindi mahirapan sa installation ng mga bakal. And of course, kung i-apply natin yan sa actual, since hindi naman kailangan talaga yung spacing, di ba? So meron tayo dito na X na. What is the value of your X? That is 2.71. So dito din, at a certain distance na 2.71, etong sa gitna natin. Hindi na natin kailangan pa ng lagyan ng bakal yan. Kaso nga lang, kinakailangan pa rin. So gawin na lang natin is, yung nakuha natin na spacing dito, is ilatag na lang natin siya dito sa gitna na lang. So sabihin natin this is. So sabihin natin at this distance, dito na lang natin siya ilatag. So gawin na lang natin siyang uniform. So, at this distance niya, dito sa gitna natin, yung spacing niya will be 275. Tapos dito is, since symmetrical lang naman, yung susunod is yung S2 natin. So maglatag tayo. So ilatag natin yan na may spacing na, yan ba, 125. Tapos yung susunod naman is yung D naman. Kasi ano lang naman yan symmetrical lang naman. Yung spacing naman dito is yung S1 natin. Okay. So, ito yung sa S1. Ito yung sa S3 natin. Ayan. So, kahit na dito lang dapat yung walang bakal. So, since kailangan naman talaga yung bakal yan sa insulation, gawin na lang natin is, ito na lang i-adapt natin na spacing dito sa gitna. So, that will be our working drawing. And that will be the design ng stirrups natin.